I want to introduce Professor Phil Greenan, who's a colleague of mine from Heriot-Watt University. Phil's based in Edinburgh, and Phil's a director, I've got it written down here, the director of the Centre for Sustainable Road Freight and the Centre for Logistics and Sustainability at Heriot-Watt. It's actually logistics, which Phil's going to talk about, is something that you came to almost in a second career. And Phil started as an engineer, worked in aerospace and materials, and then decided to retrain, do a PhD, which I think you finished in 2012 or so, came to Heriot-Watt, and has then pursued a career in logistics. So it'd be interesting to hear about what sort of made you make that sort of change in your life. And we'd be interested to hear. But as everybody knows, sort of logistics, if you live on an island, it's a huge issue. We're all constantly sort of concerned about transport, and this is something that's only going to get more challenging in a net zero world. And Phil, actually, I know you arrived last week and then suddenly had to depart back to Edinburgh, and then suddenly had to come back up to Orkney for this presentation. You've had a good sort of overview of the logistics system in Orkney, such as it is. But you don't want to listen to me any longer. But I'm just going to pass over to Phil. If you could just give Phil a quick wrap.
Thank you, Sandy. So yeah, it's been an interesting journey to become an academic. That's the first thing to say. So I've spent most of my working life in the real world, if you can call it that. As Sandy said, as an aerospace engineer, and then as a physicist. And then I decided to do a PhD. And the reason I stayed in academia is because of the freedom it gives you to do research that you choose to do. So I know the students in the room, and that's really the power of being an academic, is that you get to choose what is important, and then you can invest your time and effort. And if you're lucky and somebody gives you a pile of money, you can invest other people's time and money in doing these things. So this journey about logistics and sustainability started 12 years ago. That's when we started the Centre for Sustainable Road Freight. It was a bit of a gamble that we took with EPSRC, which is the research council that funded us. And we were in a room, and it was a sandpit. People were pitching their ideas at EPSRC, and we got to pitch last. And what we saw on the faces of the EPSRC people in the room is they were getting more and more disappointed, because people were talking about £100,000, £200,000, £500,000. So we had a bit of a whisper between us, and we decided we would go in with 5 million. And that actually was what they wanted to hear. And the reason they wanted to hear it is because it was a really big challenge. And they wanted people to understand that there was a lot of work that needed doing, okay? So the Centre for Sustainable Road Freight was set up with Cambridge University and 20 companies who came from both the technology side, so people who provided technology like Goodyear, Volvo, companies like that, and operators, so people like Tesco's, DHL, Waitrose, and so on. And then we also decided it was important to integrate the policymakers into this piece. So we got DFT and zero emission vehicle people in the room as well. We did 5 years research. The end of that research was actually our contribution to the 5th carbon budget. And the 5th carbon budget wanted to know, so this is for the Committee on Climate Change. The Committee on Climate Change wanted to know how they were going to decarbonise freight. And our conclusion was that you are going to have to make radical changes to the system, because when we started 12 years ago, people were, the narrative that was around was, you can make logistics more efficient,
and that will be enough, right? You can reduce carbon and you can save money, and it will be enough. 5 years later, it's not enough, it's not going to work, and it's going to cost a lot of money. And we're talking about radical transformation. So we went back to the Research Council and said, right, okay, this is what we discovered, this is what you gave us money to do. Give us £10 million for another 5 years. And they did. Okay, and that is now finished. And at the end of that, we've actually worked out what those solutions for freight start to look like. And they are being implemented. So it's not just sort of us sitting in a university saying this is the right thing to do, we've written a paper on it, we've done some experiments. It's actually bringing industry along, and industry are now working with us to implement the solutions. And I'll get to what that looks like. So that's the Centre for Sustainable Road Freight. The second bit there is Director of Transit. That's a new project. It's actually termed a national hub, and it's a national hub for using digital twinning processes to speed up and de-risk decarbonisation. It's a massive project that I wasn't really that keen on getting, to be honest. I was heading for retirement, and now I'm not heading for retirement, so the plan's gone awfully awful. But it is really about digital capabilities. And the point about this is that you need digital capabilities because we're starting to run out of time. We don't have the time to experiment in the real world anymore. And that's really the launch point for the rest of this presentation. Okay, so there's three sort of themes that I'll go through. The top one is what is driving the change in the transport system? Okay, what are the drivers? And they're really important. Then there's some things about the energy system. Some of what I say there some people might find controversial, just so that we're ready for a discussion. So that could be interesting, or you might agree with me, who knows. And then a little bit about what the current research is. So I've said how we got to this place. Now what are we concentrating on? So this is a bit of a complicated graph. You don't need to read it because the writing's too small anyway, but I'll explain it. From left to right, this is showing the flow of money into decarbonising everything. Okay, and this, I'm probably messing up the Zoom call now, but anyway, this in the bottom right is transport. Okay, and currently there's £170 billion being spent on decarbonising transport worldwide. Okay, it's a lot of money. Go back to what I said, it's going to be expensive. This is money that if you're operating transport now, you have to find that you didn't have to find before we started talking about decarbonisation. Right? It's also an opportunity for people providing the solutions, because that is a new and emerging global market. The blue, you're quite at liberty to ignore this next bit because I'm colourblind and I'm going to talk colours. So the blue, I think it is, all right, that's money coming from government. A lot of the money coming from government is ending up in buildings, infrastructure and energy systems. It's not ending up in transport. Okay? The money flowing into transport is from the private sector. So this is businesses making investments to decarbonise. And that total investment globally is currently adding up to about $170 billion. Right? Now, reason that's important. This graph shows you what happens if you do not start decarbonising right now. Okay, so the start line here when I say right now, I've been talking about it too long, is 2022. Yeah? So in 2022, if you had a credible plan to decarbonise transport, then the bottom band is showing what happens to GDP. And GDP goes down, and it goes down because we're spending the money on things that aren't producing productivity now. These are not low-hanging fruit that is a win-win anymore. This is actually money we have to spend that we weren't planning to do before. The top band is what happens to inflation for the same reasons, because this money is coming from the private sector and it has to be recovered by the private sector, so they put the prices up. Okay? The panel on the right, as opposed to the one on the left, is showing you what happens if you delay by just 4 years. Remembering that the start line was 2022 and we're now in 2024, we're already into that space. Okay? So there are very real economic consequences of not doing decarbonisation. Very real. And the longer we leave it, the more severe the pain gets. This is my favourite slide of all the ones I'm going to show you. Does everybody understand the term carbon budget? Yeah? Just to be clear about it, it's the amount of carbon we have calculated we can afford to put into the atmosphere before we cross the tipping point of 1.5 to 2 degrees C global warming. Now, the consequences of crossing that tipping point or going past it are very severe. Right? It's not just that it'll be 2 degrees warmer or 3 degrees warmer or 4 degrees warmer. It's that you move into feedback loops that we don't understand that get increasingly severe. So we've now started working with climate scientists a lot, because I'll come on to it towards the end of the presentation. But they're saying, right, for instance, severe weather events in the next decade will increase tenfold in the UK. That's floods and high winds. Yeah? And that's just the beginning of the story if you go past the tipping point. That's already baked in. Well, there's nothing we can do about that the next 10 years. The CO2 that's going to cause it is already out there, and there's nothing we can do. So, the amount that we can put out into the atmosphere is basically described by the area under the graph. So we have to keep that constant. Now, when we started talking about this down in the 2000s and the 2010s, we had a nice gradual line. You know, it all looked very achievable. Slow but steady change will result in decarbonisation. We'll not get to the tipping points. But what's happened since then, so this is about 2010, is the emissions worldwide have gone up. And they've not just gone up, they've accelerated. To the point of where we are now, which is about here, which means to keep the area under the graph the same, so to stay within the carbon budget, decarbonisation, which is the gradient of the line down, is almost vertical. That's the measure of the challenge that we've now faced. Now, the climate scientists will tell you that is about a 5-year period. We've got 5 years to get down to virtually nothing. The government targets in the UK are 68% reduction by 2030. 6 years away. Yeah? All this talk about 2050 doesn't matter, to be honest, because we have to do much more quickly before 2050. So we've got 68% reduction that we've got to achieve worldwide, because it's a global problem, before 2030, according to the UK government. And by 2035, 5 years later, it's 78%. So by 2035, if we stick to the plan, 80% reduction is already delivered. 2050, so from 2035 to 2050 it will be really hard to get that bit, but actually a lot of the hard work, heavy lifting has already been done. So these are the drivers for change in the transport system. And the transport system has its own inertia. Okay? So if we draw back to focus on freight, the trucks have between a 7 and 12 year economic life. So if you're going to move from a diesel truck to an electric truck, you're going to have to write off a significant proportion of that economic life. That's a cost. Okay? An electric truck will cost about £300,000. Does anybody know how much a diesel truck would cost? Or have a guess? 100? Yeah. So it's 3 times the cost. And you haven't even put the infrastructure in place to get the electricity into it. Okay? At the moment, the cost of putting the infrastructure in is being estimated at between 1 and 1.5 times the cost of the vehicles. And that's because you've got to reinforce the connection to the grid. So, there is a challenge there, and I haven't even started talking about hydrogen. That may be the controversial bit, just to give you a bit of a spoiler. Okay, so now I am going to talk about hydrogen, all right? Because there's a lot of discussion about what is the right decisions around energy to do with transport. And it's not just to do with transport, it's to do with heating and everything else, okay? So this is a graph that we put together in the Centre of Sustainable Road Freight, and it's looking at the best use you can make of renewable electricity. So it's saying, if you start with 100 kilowatt hours, what do you end up with through different technology choices? Okay, and on the left here, it's hydrogen, and it's green hydrogen, because we have to use green hydrogen, because if we don't use green hydrogen, we're using grey hydrogen, we're actually making the situation worse, not better. But we'll come on to that, or it may be a topic for discussion. So if you start with 100 kilowatt hour of electricity and you put it down the electrolysis route to produce hydrogen, compress the hydrogen, move the hydrogen around, put it into a fuel cell, and then use the fuel cell as a battery to power an electric vehicle, you end up with 23 kilowatt hours that is useful. So 100 down to 23. Okay. If you use that 100 kilowatt hour of generated electricity, put it into the grid, do the charging piece, so you're charging batteries in electric vehicles, you end up with 69 kilowatt hours. So roughly 3 times the amount of energy if you just put the electrons straight into batteries. Okay? And you can do better than that if you can avoid putting the electricity into the grid. Yeah, so if you locally generate it and you don't have to put it into the transmission and move it over large distances, then you can end up with 77 kilowatt hours. Right? Why are we still discussing hydrogen?
I don't know.
No, and neither do I, to be honest. Yeah, but we are. Okay, and going back to what I said before, about time, we don't have the time to, indulge ourselves in intellectual discussions about options that really are not working. Yeah, hydrogen may well have a role to play. I'll even go further than that. Hydrogen does have a role to play, but it's not in transport and it's not in heavy goods vehicles. Yeah? You electrify everything that you can, because you can do it now. Electrons are the easiest thing in the world to move around. Yeah? Much easier than hydrogen, that very small molecule that gets through almost everything and leaks everywhere. So here's another piece around the hydrogen piece. So this is about grey hydrogen. So grey hydrogen is where you take methane, you put it through a process called steam methane reforming, and you end up with, well, in this case, it's actually showing how you would use it in an two electric vehicle options. Okay, so you start off with 100 kilowatt hours again. I won't go through every process, but this one is what we call an electric road system. This is where we put cables in across the strategic road network, and the tractor units on the heavy goods vehicles have a pantograph system that lifts up, connects to the cables, and is charging dynamically. Okay, two good things about that. One is that you're charging for most of your journey, because heavy goods vehicles use the strategic road network a lot. So that's one good thing. The second good thing is you don't need to reinforce the connection to the grid very much. Okay, so it's something around 150 kilowatt connection, as opposed to 20 half megawatt chargers at a warehouse. So it becomes easier. So the electric road system, you end up with roughly half the amount of energy that you started with being available. If you put that into a hydrogen fuel cell, you end up with 30. Okay, so whilst hydrogen has its applications, I very strongly argue that it's not in road transport. Now, if you talk to the maritime people, they will say hydrogen has got a very big role to play in long distance journeys by ship, and I probably agree with them there. It's a possibility, and that's using ammonia. So ammonia is the hydrogen carrier, and that seems to be the way the maritime sector is moving. You can still use, for a lot of the journeys, for instance, that we experience here, when I say we, I do include myself. I've done several of these journeys recently in the last week or so. You can still use electric. Right? The one thing I haven't talked about, which is kind of interesting, is that to cope with the peaks and the troughs of demand, and to size the energy system to service the needs of the transport system, you will need some form of storage. You have to store electricity somewhere. One way of doing that is convert it into hydrogen and then put it into a hydrogen fuel cell. Okay, it works as a storage mechanism. It's not very efficient as a storage mechanism. There's lots of other ways of doing it. So hydro is one, or just flywheels are better. So there's lots of better ways of storing it. Hydrogen probably isn't the best way. If you need hydrogen as part of your industrial process, absolutely. You know, that's where it's going to have its most use. Okay. The final thing that we did on hydrogen, the final nail in the coffin, I like to think of it as, although I'm not convinced that is true, is we looked at how easy it is to distribute hydrogen. So this is a piece of work that we did for the Northern Powerhouse 11. So that's the north of England. It doesn't exist anymore because they cancelled HS2 and that's messed everything up. But anyway, when I say it doesn't exist, it does exist. It's just not, built on the same premise. So in the Northern Powerhouse 11, the question was, if we used hydrogen to fuel heavy goods vehicles, then what would the refueling system look like? And there were three options. You can centralise production. So you could do this way, the electricity comes in from the wind farm, straight into a port, you make lots of hydrogen centrally, and then you distribute it through a pipe network, or possibly through what we call tube trailers on trucks. Yeah? The other way that you could do it is that you could have localised production through localised electrolysis plants. Yeah? And the model was trying to find the best mix, given a pipe network infrastructure that we already understood, and the economics of doing the various forms of hydrogen production. And what we ended up with is there will always be a mix. Okay, so you could service quite a lot with centralised production. There's a problem with the pipes then when you put hydrogen in it, you get brittlization. You can do, a certain part of it will have to be done as local production, and some of it will have to be delivered through tube trailers, just because of the economics. Right? The real nail in the coffin, though, comes because we worked out that you have to start thinking about a delivery system that delivers hydrogen every 15 minutes to a refueling station. And if that delivery misses, the whole system starts to topple because everybody's on that 15-minute cycle. So the next one, the demand increases and they run out of hydrogen a bit quicker, and so on and so forth. So moving hydrogen around is really not very easy because of the quantities that you've got to move and the logistics involved in moving it. So that was hydrogen. Okay. The next piece of work I'm going to talk about is really about the work that we've done in designing the electric road system. So the electric road system, remember, is cables across the strategic road network, and you will have to have a mix of these cables and chargers because there will be places in the country that aren't going to be on the strategic road network. In fact, we're probably in one of those, right? So what we found is that for about £20 billion, so coming back to how expensive this is going to be, we could build an electric road system that covers most of the UK. Okay, that's quite a lot of money. Okay? And going back to one of the previous graphs, where is that money going to come from? It's not going to be government. They don't have pockets that deep anymore. It's going to be the private sector. The private sector will only make that investment if it's relatively risk-free and all the uncertainty has been removed. The investment community, when you talk to them, use the example of wind farms quite a lot. And it's quite an interesting example. My timing may be out on this. I'm an old man now and I forget years and so on and so forth. But they told me that 15 years ago, if you wanted to raise money to invest in a wind farm, an offshore wind farm, it was very difficult. Okay? And the reason was that there was too much uncertainty. There was there wasn't a consensus, this is what we need to do. Now, if you want to raise money to invest in an offshore wind farm, it's how much do you want? And the reason for that is the governments have made it absolutely clear that this is going to be part of the energy strategy. And if it's going to be absolutely clear that it's part of the energy strategy, a lot of that uncertainty and a lot of that risk disappears. That's what we need to get to with the transport system. Yeah, we need to remove that uncertainty. So these models do that. We can remove a lot of uncertainty by going through a lot of trial and error. Things that we can do in the computer sort of world, we can do thousands of times quicker than we can in the real world. And that makes a big difference because we can try and we can fail. And when we fail, we learn. It's too expensive and will take too long to do that in the real world. So we run these computer models and we come up with the figures of implementing the electric road system. So we've got those numbers. We can also come up with the number of charges, where they are and how powerful they need to be. And we can start, we haven't finished this yet, this is where we're moving to now, we can start aligning that understanding of where the charges and the power requirements are going to be for electric vehicles, HGVs, in this case, but electric vehicles generally, with the power availability. What does the distribution network look like, and what are the capacities? That work is just starting. It's horrific to me that with less than 5 years to go, we're just starting to work out, what do we need to do to the distribution system in order to make it good enough to support the transitions to the transport system. The reason the transport system, by the way, is so important is that it accounts for about 30% of the CO2 emissions. It's inconceivable that we're going to get anywhere near net zero without doing something really dramatic to the transport system. So we've run these models, and we've done a piece of work now for Transport Scotland, and we're going to extend that in some of the projects I'm going to talk about next. Of course, the biggest problem in decarbonising transport is us. It is that simple. Now, I can ask this question because I know that at least 2 people in the room are going to put their hand up. Electric vehicles. How many people have an electric vehicle? It's probably not fair to ask students whether you got in a Tesla or not, to be fair, and so do I. All right? If I'd have asked this question 5-10 years ago, I'd be lucky to get 2 or 3 hands go up. So it is moving in the right direction. How many of us are willing to... there's a hopeless bias in this audience, all right? So when I say hopeless, that's probably the wrong term to use with students. But anyway, the point is, how many of us would use public transport systems? Yeah, students all the time, yeah. And so would I, okay? But again, people aren't really using... that has changed, to be fair. So if you go somewhere like London or Manchester, people will use public transport systems. But if you live like I lived in the Lake District, where you don't have the bus services, it's kind of difficult to engage with public transport. And if you do, it's an hour-strong delivery, yes. Please.
Have you got one nod on spot after the oil companies?
Whoa. That's straight into the... well, let me answer the question directly, because it's a very fair question. I think it is. There is a problem with the oil companies, and it's that they're trying to milk their investments for as much as they can. And quite understandably, that's a business. It's not because they're oil companies. Any business will try and do that. But they've got a big transition that they have to go through. And so they're hanging on. They want us to keep using carbon-based fuel for the moment. They see that, they try to pitch that as part of the transition. And it is true, we will need to keep using it because we haven't done anything. We do have to keep using carbon-based fuels, but also what they do, and it's a consequence of their actions that they introduce uncertainty into the investment market. If I was Waitrose or Tesco's and I've got 2,000 trucks, and they're diesel, I need to know that if I move to an electric version, that's the right choice, because that's going to cost me 3, 4, 5 times as much as my diesel fleet did. I get fired if that's the wrong decision. And there's still enough uncertainty being created by this. We don't need to move away from carbon-based fuels quite as fast as you think we do argument. So it's certainly part of it. But then, we use flights. We go on flights all the time. An increasing number of my academic colleagues are saying no international travel now. And COVID showed us what we could do with things like Zoom and Teams and changes in working practices. But it's people that have to change.
I see, being an EV nerd, there's a lot of negative press about changing behavioural attitudes of your average driver. So changing attitudes of the average driver is difficult because they read in the press, everything from tabloids to the broadsheets, and it's always really, really negative, and it's always that story of chargers being blocked out on bank holidays, and it's always negative. And then, so the man in the street looks at EVs and just goes, well, the infrastructure's not there yet. But it is there. It's just not being publicised in the right way. And trying to change behaviour is the key to changing people's attitudes. And it's a media thing, I think, is a real big effect.
Yeah, and they're humans, right? So that's the point. It's the society. So the point about petrol companies, they're run by humans. The point about the press and the media, it's humans making those commentaries and creating the narrative that is very difficult for the normal person to negotiate. My recently acquired Tesla, right? The monthly charge on that is £50 a month more than a Polo. It's not, to some of us it'll be quite a bit of money. I understand that, but it's not a massive difference anymore. And the running costs, I can run that at 3p a mile. That's roughly what I'm achieving by charging overnight on a cheap tariff. So, getting the information out there to change human behaviour is also part of this modelling piece. So how do we engage society in the research that we do? And I know this is something that Susan talks to much better than me. But that's also a big factor. And then there's this piece, okay? And so now I'm moving into the space of the current projects. All this stuff about electric chargers. The problem is that on a busy bank holiday and we're driving down the motorway, we don't know whether there's going to be a charger available at the next service station. Yeah. Most of the time we can probably guess that there will be, so I take your point. But on a busy bank holiday, we don't know, because the information that allows us to operate our vehicles, and HGVs are particularly sensitive to this. Okay, so if we take this back to road freight again, an HGV, if it's running low on battery and needs to charge up, you're not talking about a 70 kilowatt hour battery. You're talking about a 400 kilowatt hour battery. It's going to be occupying a charging point for 30 to 45 minutes, and that's a very high powered charger. So knowing that it's available is important, because in logistics, if you miss that charging slot, you just miss the ferry. I'm not on the island. Instead of this being an hour delay, it's a day delay. Yeah. So information is important, and the cyber physical infrastructure is the piece that we need. The last piece in the jigsaw is how do we get the information systems to work to support this transition, which is radical, because once you move the technology, sorry, I'll come to you in a minute. The point is that we don't have the range that we have with petrol and diesel vehicles. They're going to take longer to charge. With heavy goods vehicles, that's significant. That might mean we actually need bigger and bigger fleets to be able to move the same amount of goods around. Right? We have to optimise the system. Sorry, two people.
Bigger vehicles or more?
Probably more of them. It's probably more of them, and the reason for that is that logistics is time constrained most of the time. So you've got three constraints. How much volume can you carry on a truck? How much weight can you carry on a truck? And how many destinations can you get to in 24 hours? Yeah, that last point is significant. So if you start delaying it by 1-2 hours on every journey, because every journey needs to charge, then you're going to end up with a bigger fleet, more vehicles. Yeah, sorry.
Would you hang on for the microphone if you want to ask a question?
I'm a Tesla fanboy, but I don't own a Tesla. But the fact that Elon has sort of recognised this point, and with his big semi-truck that he's developing, he's basically ascertained that delivery trucks usually have a point A to point B regularly, and then at point B he'll have another tractor unit ready for them to jump into, and then tractor number A can recharge whilst B carries on with the load. And I was thinking too in the UK, like Tesco for instance, go up to the Pentland ferry, they've got a set route. So we have that surety of, I don't know where Tesco start out from, say Inverness distribution point, and it's going to go up the A9. That's a set route, I'm guessing, every day. That's a constant. It's never going to deviate off into a small village because of its size. So we have that definite route, miles, range, to have something in place for them to perhaps swap tractor units to then carry on.
Okay, so whilst that is true in some cases, and I've dreamed of this moment, Elon Musk is wrong.
Your car won't start when you go back out.
Yeah, well, yes, if he's listening, you could probably turn it off remotely. Yeah. Anyway, he's wrong because we've done the work, and this is why academics need to be involved in the loop. All right, so we've looked at now about 20 fleets, okay, and for most of them, every truck during the course of a year will visit every destination. So whilst the route is repeatable, the truck doing it isn't. And that's what you get with diesel trucks, is you've got that flexibility. The same truck can do any of the journeys. Whereas, sorry, there's some microphones flying around.
It does go back to the old stage posts where you used to have horses waiting.
Yep, Pony Express.
But, okay, right. So, but instead of changing the actual tractors, why not, is it possible the design of the trucks goes that you actually just slot in a new battery and the same truck then goes on its route?
Okay, right, yeah, that's a good question, all right. And here's the hard economics of it. So about 40% of the cost of the tractor unit is batteries. Right, so 40% of that £300,000 is batteries. If you're going to operate that system, which would work as a system, you're going to need roughly 1.5 times as many batteries as you would if you could just kept the battery in the vehicle. And it takes time because these batteries are really heavy. And we've looked at these options. We've looked at putting batteries on the trailers so that you could get to a staging point and swap to a trailer that's already pre-charged. And they all work, but they're all terribly expensive. The best one is put the cables along the strategic road network and charge as you're driving. You never have to stop. Yeah. So, but the cyber physical infrastructure is absolutely key. So what we mean by cyber physical infrastructure is the connectivity, the comms. The 5G and the 6G networks will allow so much to happen that will take the sting out of this decarbonisation argument. For instance, 40% of your operating cost as an HGV operator is the driver. If I can take the driver off, I reduce the operating cost of that vehicle by 40%. Now, put aside the social arguments, because there are some, I fully accept that. But if you can reduce the cost by 40%, I can do a lot of stuff that I wasn't going to do before. Furthermore, because there's no driver, I don't have to respect driver operating hours legislation, which means that they have to stop for 45 minutes every 4.5 hours. So that goes. They can operate 24 hours. Yeah? They can charge themselves, they can swap trailers, and all sorts of things open up. But you need the cyber physical infrastructure in place. And the same goes for public transport, right? Imagine a world where you don't have to wait for a bus because there's lots of autonomous pods floating around Kirkwall in this case, waiting for a phone call to say, I'm at X and I want to go to Y. And the communication that you would have with that vehicle then has to be, here I am, this is where I want to go, the vehicle telling you, this is where I am, and I'll be there in 3 minutes or 5 minutes or 10 minutes, whatever it is. Yeah? Utilisation of the fleet, whether it's passenger cars or heavy goods vehicles, increases enormously once you bring in autonomous versions. Now, this is two surprising facts about autonomous vehicles. All right? Is it legal? Is it a legal requirement in the UK to have a driver in the vehicle? Hands up if you've got a view on it.
I would have thought yes, but clearly it's going to be no.
You're right. It's no. There is no legal requirement for the driver to be in the vehicle.
Right,
Right?
okay.
And that's because when we wrote the legislation, right, there was no choice. It was obvious that the driver would always be in the vehicle. But there are now companies operating vehicles in the UK with remote drivers. What is the advantage, you may say? Well, the advantage is that they can operate about 6 vehicles.
No, my lord.
Yeah. Because they're not engaging all the time. Right, so there's a level of autonomy that says that you have to be available to step in when there's an emergency. That's what they can operate at. And the DFT, the Department for Transport statistics, is that they can operate about 6 vehicles. That's legal now. You want to go and leave and set up remote driving in Kirkwall, nobody could stop you.
All the council will.
Well, they might try, but I don't think they could, because it's legally been established that you don't need to be in the vehicle to drive it.
Sorry, just a bit of an in-joke.
But I don't think it's an in-joke here. I mean, it's everywhere, to be honest. So the next thing, the Department for Transport expects to see fully autonomous vehicles on UK roads by when? Have a guess.
2026.
It's 2025. All right, next year. The Act is passing through Parliament now. That's the stated intention. They're putting out consultations now on autonomous vehicle for mobility, personal mobility. I got the email yesterday, and it's all part of this 2025 push. They see that as a way forward. And it's not, when I say government, I mean government. It's not a party political thing. It's everybody's in the same boat on this. There's no reason for it not to be happening, and they want the UK to be leading in the space. So by 2025. Now, interesting point. If you're driving down a motorway, and some of you will have experienced this, with the levels of autonomy that you can get now, it's relatively safe. Yeah. If you're driving down a country lane, it's not so good at the moment. And one of the reasons is that the vision systems doesn't recognise the edge of the road very well on those sort of situations. So, peculiarly, with this cyber physical infrastructure, one of the requirements is paint lots of white lines so the vehicle knows where it is. Right? So there are grounds for optimism in this future transport system. So, in summary, energy inputs are changing. Electrify what you can. Avoid hydrogen unless you absolutely have to go down that road. Some modes won't be electrified. Those are going to be hydrogen or ammonia or e-fuels or something like that. We do need these digital capabilities. So we've got 2 big projects now, one that we're running for the UK, and the other one we're part of, we're not running it. The big one is called Transit, and it's £50 million. It's got huge industrial sponsorship as well as government support, and that's looking at developing these digital capabilities. How do we connect the different models that exist with each other? So getting interoperability between the models and making them digital twins. So digital twins is where your computer model takes real-time data, does something really quick with it, and feeds back to the system, says, right, change something in the system to be better. That's a digital twin, that feedback loop. What we want to do is build lots of these and then have them joined up into a system for the UK. So that's a 5-year project. This second project, which is called DARE, I can't remember what DARE stands for, which is a bit embarrassing, but it's about resilient infrastructure. And the reason that that project has got off the ground is because we recognise we're probably going to fail. We've started to realise that we probably are going to have to face climate change and all the consequences and the escalating threat. So we need a resilient infrastructure to make sure that we can carry on functioning. That's a very sobering project, and that's the one where we're talking to the climate scientists, and they are really nervous because they think their models are underestimating the problem. That's the position they've now got to. And it's kind of obvious because the models are trained on historical data. But if your data is going like that, then actually the models are still doing that. Yeah? And there's no way to work that out. You know, except, yeah, the prediction was we would be here. We've ended up here, the models are wrong, let's correct the model. And they're in that loop now of correcting all the climate change models. And it's very sobering. In terms of further work required, we need to remove risk and uncertainty to enable the investments to flow. So we starting a project in July with 10 companies, and we academic institutions have acquired the vehicles that we are going to lend them so that they can start experimenting with them, start running them on actual trials. And we've acquired chargers that we're going to put on skids that we can move around the country. They're high-power chargers, and people can evaluate the technology. So, and the reason we can do that is we've run the computer models and we know where to focus our attention. So, if you talk about transport generally, public transport will play a very important role. We need to get people out of cars, out of car ownership actually is the problem. We might still have cars, but those cars will be sort of publicly owned, moving around autonomously, serving the mobility needs of everybody. And we need to be inclusive about this. You know, it's really frightening to an old person like me that as I'm getting older, technology is leaving me behind. And yet the world is becoming more reliant on it. So we need to find ways of making technology accessible and inclusive. And I haven't even covered disabilities in that discussion, which obviously is very important. We need good cyber physical infrastructure. Really difficult when you make this point to people who don't even have connectivity now. You know, and they're turning the 3G network off, and we're talking about 5G and 6G. In our transit project, we have a license to have what they call pop-up 6G networks. So we can go into Glasgow or we can come to Kirkwall and we can set up a 6G network. And it's amazing what we can do, right? We can see people waiting to cross the road, and we can see that the artificial intelligence can recognise that they've been there for a long time. And we can alert the emergency services to that, so people can go out and help those people if they need help crossing. It could be, we don't know whether they're blind or deaf or got some other reasons for not crossing the road. Or maybe, as we found in some cases, when we've had the 6G network on bridges, we can see people walking up and down the bridge constantly. And we alert the emergency services because that's a suicide threat. Now, obviously, you want to save that person's life, but also by doing that, you avoid all the disruption you would get if the worst happened. So 6G and 5G networks and pop-up networks, very, very important. And we've got to really think about the rural versus the urban. So most of this is very easy to implement in the urban environment. Well, I say very easy, I mean, we can see the way to do it. In the rural environment, we don't even have a way yet. And that is where I stop. probably gone on for way too long.
Thank you. Thanks very much, Phil. I mean, you stimulated a few questions as you went along there, interestingly, but I'm sure there's one or two other questions out there. There's got a hand up already. If you're using the mic, could you hold it closer than you want to your mouth? Yeah.
You said, one of your first slides said that there's 170 billion being spent worldwide on this sort of thing. We're no longer part of the EU.
Yes.
You had EPSRC money. Are you able to dip in? Are you able to expand that by getting EU money as well, or what's the collaborative?
Yeah. So we do have access to EU funds again after a short holiday and a degree of uncertainty, and we've always carried on collaborating with Europe. It's not just Europe, and we've set up centres in China, India, Africa, all doing the same thing. With groups of researchers sharing their ideas and accessing their own government funding. The real challenge is not so much the research now, because I think that's recognised that a lot more money needs to flow into decarbonising transport, and that's happening, to be honest. It's one of the top 5 investments in the UK now. I think the problem is getting it out of the private sector. So what we need to do is do the research and make sure that our pathways to impact, as we call them, is addressing the financial institutions. You know, are we answering your questions that allows you to free up funds to be invested in decarbonising transport?
Okay. Question.
Thank you. Thank you very much. I was wondering, for example, if in the case that everything aligned and we had the 20 billion pound, I think you mentioned, for the strengthening the grid and everything, well, these systems are still reliant on humans, right?
Yeah.
And there will be still people who need to be maintaining the floats, the grid. People making policy, right? So which will be the kind of obstacles, the barriers in terms of having skilled people who will be able to face this, right?
Yeah.
The 6 years is not really a long time, right? So
there's a massive skills gap, all right? And anybody who's got an electric car will have experienced the difficulty of getting it insured. And that's because there isn't the skills capacity to deliver the maintenance and support to the new technology. And we haven't even talked about the infrastructure piece yet. So there's a massive re-education, reskilling process that has to take place around transport. And it has to start now. You know, all sort of radical changes have been resisted because they take jobs away. But not generally speaking, I think all of them have created more jobs in the medium to long run. And these new jobs that you're talking about, actually, we need to start preparing the ground for them, because 5 years is no time at all. If we don't start doing it now, we don't have the institutions, the courses online, then we'll all be for nothing, because we'll just have vehicles that don't move.
So Neil's got a question. Just to make a point about that 20 billion, it's a vast amount of money, but I'm thinking about Scotland and offshore wind that's going to happen. It's been areas have been options have been given to lease areas. That's 27 billion pounds worth of investment. So it's a scary amount of money, but it is the sort of order of magnitude of spend that we are already looking at in other parts of the sector.
The difficulty, so on the electric road system, which is the 20 billion pounds, the real difficulty is who is going to do the work? Who's going to own that system? Because it doesn't exist now. So if something exists and it's extending what they're doing, that's one case. But when there isn't actually any company willing to take it on or has a track record in the space, where does the money come from? Because the government don't want to do it. Yeah, that £20 billion is where HS2 started. They're absolutely terrified of another one of those. So it's really tricky.
Neil.
Yeah, that was really interesting, Phil. Really enjoyed that. There's a lot of interesting stuff in there. I've got about 4 or 5 points I just want to touch on. You've gone through, sparked a bunch of bits and pieces. One piece about the last point you're making about the skills, we've been very, very fortunate here that we've had a very enlightened driver here, or sort of mechanic here, Conrad Omond over in Stromness, and he's one of the, was it Herva? Hevra, which is John knows which stands. Yeah, anyway, it's the electric vehicle sort of maintenance side of things, and he's been brilliant about doing things. So we've been very fortunate that we've got the capacity to actually have cars serviced here. It's also good that UHI has actually got training kit for training vehicle mechanics on EVs. So some of their stuff is starting to roll, which is no pun intended there. There was a bit about the urban versus rural. We did some work through OREF some time ago when we logged people's vehicle mileages every month and got them from EVs. And the interesting thing that we found there was the average mileage that people were doing per day was about 24 miles a day in an EV. Now that's greater than the average mileage that cars do in Scotland.
Yeah.
And the point there is that urban driving is easier to electrify than rural because of the range side of things as well, which is slightly counterintuitive, except of course the people in rural areas have inevitably got off-street parking, or a higher proportion have got off-street parking. So that changes the charging model quite considerably. And I think there's always a risk that we end up with regarding these problems as monolithic rather than in components.
I agree. I absolutely agree. I think that the counterpoint to off-street parking is very often they don't have the strength of connection required to be able to deliver the charge from the substation. So that becomes an extra dimension.
But the thing we found, so with the average of 24 miles a day, is that sort of 3.5 miles per kilowatt hour, you're looking at sort of 7 or 8 kilowatt hours of electricity need to be delivered, and on a 7 kilowatt charge that's an hour, but probably it's a dribble of a kilowatt over an extended period, and certainly there's a big opportunity in these rural areas to concentrate on the electrification or the provision of chargers at houses as the normal way of going on.
It's a good point. I think that's true. Yeah.
Another little bit of snippet of information you might be interested in. The Orkney International Science Festival is always great at turning up nuggets, and there was a teacher from North Ronaldsay a couple of years ago who was explaining how there was some project whereby schools were being able to apply for little robots, sort of autonomous vehicles, and they got one in North Ronaldsay. Now I don't know what the population in North Ronaldsay is, 4 I think, and anyway they'd used this and done some programming work, and they actually got this sort of a robot that would deliver about an A4 paper box versus size of kit or materials, and they programmed it to go from the shop to the school, and actually did last mile delivery autonomously with food for the school, for the kitchens. So on the public highways, didn't worry too much about the regulations, they just went and did it. That's the advantage of North Ronaldsay, but there's a little snippet. And the final bit I just want to talk about very quickly was about hydrogen. So at EMEC we have been making hydrogen, and I completely agree with your conclusions in there, which is electrify everything you possibly can, and hydrogen has got very, very limited uses. We absolutely don't believe it's got a role in road transport, and some work's been done here, and batteries have basically eaten that completely. So that's the thing. We're also not convinced it's going to work in shipping in a gaseous form, and we certainly aren't convinced it's going to work in aviation in a gaseous form. But sticking the molecules to something else really quickly is a good way of doing it. So nitrogen for ammonia, or carbon, if you can get captured carbon out of the atmosphere for aviation, that's where we see it going. So I think you're spot on with your calculations there and the approach to electrification. I did have a question, I've now forgotten what it was.
Sure, it'll come back to you.
Jonathan's got a question there, and then.
So I think I've got a really good friend called Ewan McTurk. He runs a YouTube channel called Plug Life TV. Ewan's a battery chemist, and it's interesting that looking at all the stats and human behaviour, when we look at Norway, my gut feeling is they're about 5 years ahead of where we are in the UK. And just the physical, well, the mental thinking of a Norwegian driver is so much further ahead. So their uptake of EVs is something like 90% of registrations over the last 2-3 years have been pure EVs because of tax incentives and disincentivising people to have fossil fuel cars. But when you went over there to Oslo, you found it really interesting. There were some very old EVs with 50-60 mile range, parked up, not plugged in. Very high rise, built up area, lots of flats, but they had lots of central hubs with, you know, a dozen or so rapid chargers. And there was like one car on there. And this was just a normal day, autumn, I can't remember what time of year it was, but he was staggered. A, the amount of EVs he saw on the road, and secondly, how many were not actually plugged in, given relatively low range. And it's just this human behavioural change that's taken place in Norway, where people aren't just obsessed with, I live in a flat and I can't have an EV, because they've got these hubs accessible when they need them.
Yeah.
You got any thoughts on that?
I have lots of thoughts on it, to be honest. I think the solution of having these sort of centralised hubs is a good one. And the models tell us that as well. So, you know, in complete agreement. The problem is that the fragmented nature of the regulation and the society governance structures in the UK really don't lend themselves to making these so you can have a decision in Penrith, near where I live, and it's different to the one in Carlisle. And it's that really sort of stops things happening, because that produces uncertainty, you know, and it's the coordination. We're just not very good at it anymore. Yeah.
Got a question at the back there?
Hi, so thanks for the talk. You talked a lot about the uncertainty essentially blocking private investment, and you know that obviously is a really classic thing. You get private investment wants a lot of confidence in stuff. Doesn't that kind of undermine the whole point of the private investment being the one that needs to drive this? Doesn't it have to be government money in order to kind of front load it? And obviously you've just discussed some of the problems with, you know, the way the government functions in our kind of like planning and things like that, which might limit that. But from a theoretical point of view, wouldn't that kind of structure make more sense? And then also on top of that, the ownership element, like if these companies are building these electrified roads and then, you know, have ownership of those, like you're kind of creating, you're basically maintaining the same system of like large quantities of freight moving constantly, rather than, is there something you could do with like combining freight to reduce the number of vehicles on the road in totality, but maybe also reducing the speed of delivery of certain items and that kind of thing? So you're trying to bring those two elements out. So it's kind of a two-part question.
Just remind me of the first part again.
So the first part was
not all of it,
about where the investment lead was coming from, like private versus government, and the speed at which it needs to be done.
So the investment lead, there's a lot government can do to create the right environment for investment. So, you know, but what the government needs is still the same thing as private investors need, which is they need to know that this is the direction of travel and we're going to go down that path. And they're still not in that place, to be blunt. That's partly why they're funding these big projects, is to try and get into the space where they can wrap the right sort of policy and regulation around the problem that allows people to make the investment. There's a second thing they can do, and they've said we're absolutely not interested in doing it, which is they can underwrite the investment. So, and the reason that they're not interested in doing it is they've had their fingers burnt with nuclear. So they underwrite the price of nuclear energy. It's very high, it's too expensive, fingers burnt, don't want to get involved in that discussion. Again, thank you very much. So the second part of your question was? Remind me again. Yeah.
Wait a minute. Reduction of vehicles on the road. So like
demand. Okay. Yeah. So yes, there is. So if we move people to public transport, You get more people travelling on a single vehicle. Absolutely. You know, the car is the worst invention ever. It's usually, you know, about 3 tons of metal moving one person around. Doesn't make sense. So if you can fill a vehicle, it makes much more sense. So public transport plays a part in that. In terms of freight, it's a very interesting discussion, and that's because the inventory, the amount of inventory you carry in the supply chain is dependent on how frequent you make your deliveries. Okay? The more frequent the deliveries, the less inventory you carry. The slower the delivery cycle, the higher the inventory levels. Inventory costs a lot of money, and that's why companies don't do it. So if we as consumers are prepared to pay the price for that, so we're back to human behaviour. If you're willing to accept that food will go up by 10-20%, which is kind of the number we're thinking of.
Inventory was cheap compared to diesel. It's not cheap compared to diesel.
No, actually, for most products, inventory is more than the diesel. So inventory holding cost is about 20% of the cost of sales.
Right. Well, my question was the just-in-time shipping, the whole way, the whole value proposition of what gets shipped where.
Yes.
Is all got the stink of fossil fuel all over it, right? Though every one of those decisions had an assumption of a low-cost fuel.
Yes.
So when you said originally at the very beginning, we got to redo the whole system, that is absolutely true. So the way things are moved, but also what is moved and when. And then I got one hack for you, and that is the budget isn't the right word any more than target is the right word. If we hit the target of 2 degrees C, that wasn't a good thing. And it's not a budget, it's a load to failure. So you can have that hack. That's a good word.
I agree with you. The wrong terminology.
And I got one more thing. Are trains the public transport of freight?
Right, okay. So this is another discussion. Okay, in the UK, so trains are a really good way of moving freight long distances. Yeah. So across Europe makes a lot of sense, and they're investing in the train network to do exactly that, to move stuff from Germany to Spain. Yeah, and lots of other different places. In the UK, we are a relatively small island, and the problem is that you have to move the stuff from the factory to the railhead. Thanks to Dr. Beeching, the railheads are few and far between. He was an academic, by the way. Anyway, right. So the distance you move the stuff to the railhead is on average about 50 miles. If you can't fill the vehicle going back, that's a 100-mile round trip, and you do the same at the other end, you can get to a lot of the UK in that distance, and it's quicker. So you get the inventory benefit as well. So our problem with rail is twofold. One, it's not connected enough anymore. It doesn't go to enough places. Two, we're not moving things enough distance in order for it to make sense. So there are some very competitive rail routes, you know, from Daventry to Glasgow, for example. Tesco's use that all the time. It's very well connected because we've built a Tesco warehouse at the railhead at Daventry and another one at Glasgow. Right? If more companies can do that, then yes, that will look after itself. However, there is a problem with the rail network in the UK. Okay? The problem is that we were the first people to start moving stuff by train. Right? And the trains then were very small, which means the tunnels that we built are also very small, which means that you can't get the freight trains through a lot of the infrastructure anymore, which means that they have to go long, circuitous routes. That's still a problem in the UK. In Europe, it's not such a big problem.
Right, I've got 2 hands, so there's 2 people who've got questions. I'll take one more after that if there is one, and then I've got a proposition for Phil.
Yeah,
question at the back, quickly.
Hopefully a lighter question, this one. What 3 things would you do in Orkney?
Oh, now, having experienced it, it's a bit of an unfair question because I guess I'm a tourist is the first thing to say, so I don't actually have to live here. But if it's anything like where I do live, which is not dissimilar, the Lake District, I would say public transport, flexible bus service, so demand responsive transport system would be a big plus. Demand responsive means that we guarantee to get you from wherever you are to wherever you want to be within 15 minutes of what it would take you to do by car. There are places across the world that have done this very successfully, and it requires government support. It's a subsidised service, but that would get people out of cars into public transport, and that would be a good thing, I think. The second thing I would say is information. Right? As a visitor, it's quite hard to get the information I want to be able to get around the island. That's the cyber-physical infrastructure. I've lost count of the number of lanes I've driven down thinking there must be a car park at the end of this lane somewhere near the beach, and there isn't. Right? So that would be the second thing. And the third thing would probably the same thing, but it's about charging infrastructure. So information about charging infrastructure. I didn't come in my Tesla as it happened. I came in a dirty diesel camper van. Yeah. Anyway, that's another story. But yeah, if I was here, you can see petrol stations, right? You're driving down the road, they've got big signage. Charging points are not so easy to find and locate.
Yeah.
That's an ICNZ programme sorted out, isn't it?
Yeah, that's next agenda.
Okay, yeah.
Neil.
I remember what my question was, which was, in terms of the distribution process, the logistics of getting stuff to people, have you got any feel for how much of that is like last mile type delivery activities and how much is the long haul freight? So in our case, we obviously have got the ferries which come up, which are very fuel inefficient, and then a lot of our stuff is last mile. But I just don't know what it works like in the rest of the UK, and I don't know if you looked at that in your logistics work. Yeah. That proportion.
Yeah. We have. I'm trying desperately to remember the figures. Well, what I can say is long haul accounts for the majority of emissions, right? And that's because you're moving lots of stuff in a single vehicle long distances. Last mile, you tend to be moving little chunks of stuff, a lot more vehicles because of the time constraints, actually. So this is something that's misunderstood, but relatively short distances. So I think as things stand, it's probably nearly a 50-50 split across the UK, and this is post-COVID. So pre-COVID it would be heavily biased towards most of the emissions were coming from heavy goods vehicles. Post-COVID we're all getting deliveries to our house and we got used to buying stuff on Amazon and so on and so forth. The reason that last mile takes up a lot of vehicles, needs a lot of vehicles, is because there's a limited number of destinations they can visit in the day. It's a time-constrained activity. Now, if you can improve that, you could reduce the number of vehicles. So this is about having places where you can stop, instead of stopping at every house in the street, obviously an exaggeration, if you can stop at the street corner and throw everything off quickly, I probably don't mean that, but you get the general idea, get it off the vehicle quickly to be collected, then that is going to get you round a lot more destinations. And they actually do this in London quite well because they've got pedestrianised areas now. So they have places where they just drive the van up, out it all goes, and then volunteer pedestrians come and collect it, or they're even paid by the hour. They just get a text on the phone and say, right, there's some parcels in your area need delivering. Start the app, stop the app when you're finished. That's what you get paid.
Excellent. Question at the back, or last question?
Really interesting to hearing about your work. What can you tell us about similar work being done in China, India and America?
Yeah, well, that is a good question. Okay, so interestingly, in China, a huge amount of effort on electrification and decarbonisation. You know, China, although I could criticise it in many perspectives in terms of the amount of carbon that's being generated. In terms of electrification, they're actually moving faster and further than any other country in the world. So that's the first thing I would say. On freight in particular, the Chinese government are supporting the academics that we work with there very well, to the point that they can outpace us in terms of academic investment to solve the problem. So that's China. India, their government have made public a plan to put in an electric road system. We haven't done that. Right? In both China, India and America, the governments are subsidising green investments much better than here in the UK, and that is happening in Europe as well. Africa's a very interesting place because they have more of a blank sheet to work with. They also have a very unreliable electricity distribution network, which sort of says probably can't electrify freight there. So their focus is now building out the energy infrastructure in order. We've got a lot of the energy infrastructure in place. In Africa, that's not necessarily the case. But with a blank piece of paper, you don't have to take down existing infrastructure. If they're smart, they can leapfrog the West with cyber physical infrastructure, for instance.
Well, and with right rail.
Rail's an interesting one because those countries that have a good rail network or a reasonably good network, places like South Africa, still operate old railways, the dirty railways. But yeah, it's a good point. They could put in a good rail infrastructure.
Okay, that was the last question. I'm going to be a bit cheeky here and steal a little bit of time. It's kind of proposition for Orkney. Your view on it. We've been testing lots of bits of kit here, drones and autonomous boats and the people coming, and that's all good. But should we perhaps, I was intrigued by this digital twinning, and also you mentioned the urban and the rural and the challenges in the rural. We've got a complex system here, 16 inhabited islands, lots of ferries, we're at the end of a long supply chain, we've got public transport, extremely challenging situation, distributed population. Should we be, instead of testing little bits of kit, should we be building a cyber-physical model of Orkney to test rural solutions?
Well, I think yes. And I think the technology is there and the partnerships are already in place to do that. So, to give you some idea of sort of mainland UK, why I think this is a reasonably good idea. We haven't talked about it before now. The National Centre for Digital Twinning have been running an exercise to build a digital twin of the Isle of Wight for that reason. Yeah. Now, the Isle of Wight is a relatively simple scenario compared to Orkney because they don't have the islands and those connectivity. It's got a bigger population. But you could build on the previous work that was done here with Reflex, for instance. But yes, and I think the mechanism's in place. We could probably work that into transit somehow, of having a pop-up network and building a cyber physical infrastructure for, say, Kirkwall, and saying.
You get 6G as well.
Yeah.
Okay.
Well, the clue's in pop up. Because when it pops up, it pops down when it's finished.
Okay, on that note, I'm going to thank you very much. Thanks for the audience for coming along.
Well, thank you, I enjoyed it.
So many interesting pieces to pick on there, but I'll thank you in the conventional way. Thanks, Gary.
Thank you.